Hello friends, welcome to my channel. What if I told you that a microcontroller can keep track of time and even generate perfect and precise signal all without writing a single line of code inside the main loop? So this secret lies in the timers and counters and various values and modes associated with them. So in this video we are going to discuss that what are the hardware timers and counters and bits associated with both of them. So let's get into the video. First of all, let us discuss what are the timers. So timer is nothing but a basically hardware register which is physically present in your microcontroller. This is a very important point, right? That counts the clock pulses from the system clock or the microcontroller clock. So what is the clock in case of microcontroller? So this is the image of the Arduino Uno. You can see here a small metal cap, right? Which is called the crystal oscillator. And the task of this crystal oscillator is to generate the clock pulses, right? Perfect and precise clock pulses so that all the tasks within the microcontroller can uh, synchronous properly. And this main chip you can see here, it is called the Atmega 328P, which is a main microcontroller. So timers are physically present inside this microcontroller, and clock signals are generated by this crystal oscillator, right? And timers count these clock pulses. Now these are the some key points regarding the timers. First one is the timers increments automatically with every clock tick. Like you have observed your household clock, what it does, it counts the every second starting from 1, 2, 3 like that. So similarly, timers also count these clock ticks, right? So once it reaches its maximum value like 255 for 8-bit timer. Now bit in case of timer represents that how many values or how many clock ticks it can count. Suppose for 8-bit timer, the timers can calculate or count 2 to the power 8. That means 256 number of ticks, right? And similarly for 16-bit timer, the total number of ticks will be 2 to the power 16. That means 65,536, right? So once it reaches maximum value, that is this in case of 8-bit and this in case of 16-bit, starting from 0 to 255 and 0 to 65,535, right? Suppose the timer is calculating the ticks 0, 1, 2 like that up to on reaching 255 the timers overflows. That means over it will start from again 0, right? 0, 1, 2, then again after reaching 255 it will again overflow and count from starting 0, 1, 2 like that, right? So that is what I want to say here. Once after reaching a maximum value, this is a maximum value in case of 8-bit and this is a maximum value of clock ticks in case of 16-bit, right? It overflows. So overflow, that means starting from 0 again and starts again, right? So timers are mostly used for time related tasks like generating delays between the events, measuring time intervals between the events and producing PWM signals and triggering what are the interrupts at precise intervals. So I will discuss that what are the interrupts in the upcoming video, right? So in this video I am going to discuss just the timers and the counters. Now you might ask that if timers are used to generate delays, then why do we use delay function? So the answer of this question is that timers can run in the background of your program which you have written in the microcontroller, right? Without stopping the main loop. And they can also trigger the interrupt after a delay or on a schedule basis. So the interrupt can also be scheduled, right? So if I show you the example of delay and the timer, you can see here I'm using a delay 1000. That means it will stop the every operation present or the currently running in the microcontroller for 1 second, right? No operation will be performed for this duration. But if you are using timer, that means you can perform any operation for this time period, right? So this first line is also kind of delay. You can see if millis minus previous time is greater than 1000, that means we are defining that if a time period between two events is greater than 1000, then perform some operation inside this condition or the if statement and updating the previous time to the current time. Millis always give the current time, right? So this is the timer case and this is the delay, right? So in timer case, you can perform any operation within this period, right? Without stopping the main loop. So this condition will be written inside some main loop, void loop, right? Void loop. So that is why delay stop the every function. Every function, that means it will stop the loop function as well for 1 second or whatever time you gave inside it. But in case of timers, you can perform any operation for this time period, right, without stopping the main loop. So that is the difference between the delay and the timer. Now let us move on to the examples. So timers basically calculate the clock pulses. Then how we can measure the time using the timers? Then there is a formula for this, right? So time is equal to timer count into prescaler. So I will discuss that what is prescaler here, right? Divided by the clock frequency. So timer count, that means how many ticks it has been counted by the this timers, and what prescaler you are giving, and what is the clock frequency. So in case of Arduino Uno, the clock frequency is 16 megahertz, right? So from this formula you can calculate the time. Now if you talk about the examples, then timer 0, timer 1, and timer 2 are some of the examples of hardware timers. So timer 0 is of 8 bit, right? That means it can count the number of ticks from 0 to 255. That means a total of 256, right? And this timer is used for millis, micros, and delay, right? And if you talk about the timer 1, then it is a 16-bit timer, which is used for servo libraries and high resolution PWM signal. I have already discussed that what is the PWM signal in my previous video. You can check out that. And about timer 2, it is of 8-bit and it is used for tone generation, right? So I will discuss that what are these three timers. Now let us discuss what are prescaler and what are postscalers, right? So prescaler is a numerical frequency divider which is placed or used before the timer starts. And why it is used? Basically, it is used to slow down the incoming clock so that the timer doesn't increment too fast, or to extend the range of the timer so that we can measure longer time intervals or generate the slower frequencies, right? So let us understand this with the help of an example. We are taking Arduino Uno for example. So system clock frequency in case of Uno is 16 megahertz. And if we are using prescaler as 1, that means time interval between every 2 ticks is 62.5 nanoseconds. So it is calculated like this: 1 divided by 16 megahertz. So this value 1 divided by 16 will be 62.5 nanosecond, right? And we are using prescaler as 8. That means time interval between every 2 ticks is 0.5 microsecond. How it is calculated? You just need to multiply the numerator by 8. So multiplied by 8. So this value will be zero point 0.5 microsecond. Similarly for prescaler 64, multiply by 64, right? So in this way you can say that the range of the timer is going to be increased from this side to this side, right? So prescaler is equal to 1, the clock, the time period between 2 ticks is this much, and for prescaler is equal to 1024, the time period between 2 ticks is 64 microsecond. So you can see that the range of the timer has been increased, right? So without using prescaler, that means prescaler is equal to 1. So without prescaler, also called prescaler as 1. Maximum interval between this much, right? 4 millisecond. Why? Because this is the time interval between two ticks, and how many ticks has been occurring? This much, right? So the total time of overflowing will be this much, 4 millisecond. So in this case, that means without prescaler, the timer will overflow very quickly in 4 millisecond. But if we are using prescaler as this much, 1024, then the maximum interval will be 4.2 seconds. So we have increased the range of the timer, right? So the timer doesn't increment too fast in this case, right? So 4.2 second is now the new a total time period of overflowing for the timer if we are using prescaler as 102. Now let us have a look at postscaler. So basically postscaler comes after the timer, usually after the overflow, right? And it doesn't affect how fast the timer runs. That means we do not change the range of the timer. Instead, we control how often the interrupt happens. So postscaler is related with the interrupts. Sorry, right? So it is related with the interrupt. That means how many times the interrupt will occur. So that is decided by the postscaler. And why do we use it? To reduce the interrupt frequency. That means how many times the interrupt will happen. And it gives the CPU less work. and to generate the slower periodic signal without changing the timer prescaler. Suppose the timer overflows every 1 millisecond, so the interrupt will occur every 1 millisecond. But with a post scalar of 10, the interrupt will trigger only once every 10 overflows. That means the interrupt frequency has now been increased from 1 millisecond to 10 milliseconds. Now this time the interrupt will occur every 10 milliseconds and not 1 millisecond. So that means we have increased the frequency or the interrupt frequency. That means how many times the interrupt will occur. It will occur every 10 milliseconds. So that is the meaning of the post scalar. Post means after the timer and pre means before the timer.